let's go with it. Hi, everybody. Who's an engineer here that actually knows what fault trees are? Okay, well, then I'll make sure to cover that in more depth. I'm not going to teach you them, right? But boring. It's boring for the people that are providing opinions if you're using expert-based stuff. It's boring to hear about if you're the consumer of the information, right? So it's like, a lot of people don't like to admit it, but it seems to be true, especially in the domain I come from. I come from the security world. And security is all experts, getting experts in the room. The experts are being forced to do things they don't want to do. The facilitators are unhappy about the response. Everyone's angry. At the end of the day, people leave unhappy, feeling as though they didn't achieve anything, and it just goes on and on and on and on like that, right? So I was like, how can I make it fun, right? That's what I'm going to talk about. One thing I did to make some aspect of it fun today. So that's me. Riskologist, study how risk analysis is done, right? As well as gaming. So you put both together, you have my research field. It's called the gamification of risk management. That's my risk field. That's my research field. And I put it on my PNT dossier, so it's true now. So, fault tree poker, right? I'm going to talk about that, but first, here's my outline. I play with PowerPoint. I already shared a little bit about me while we get the stuff set up. I'll show you some little examples of other things we're working on. I'm going to talk about what it is, how I made it, does it work, which is a big question these days with serious games, right? And then what's next for it. And let me tell you right now, I am an engineer. I have never once, ever, before coming to this place called Penn State, ever did human subject work. Ever, right? I didn't even know IRB existed before I came here, right? So I had to figure it out all on my own, and I did it through this experience. So I'm not going to just talk about what I found. I'm going to talk about where I messed up, right? Which might be interesting, right? So, and here's my ground rules. Interrupt me, challenge me, question me, share me, engage me. Just don't stay silent. Raise hands. Keep it going. You know, if you see something that's cool or see something that reminds you of a story, please offer it. It's lunchtime. It's fine. I don't want to be the guy talking, even though I tend to talk a lot. Ask her. She knows. Right. So first, this kind of set the stage. I talked about the risk management type study, and really I'm looking at how do people go about answering these questions and doing the stuff. Not so much the topic it's focused on, but this is what I'm focused on. Risk assessment, communication, control. I want to study risk. I want to tell you about it. Then I want to do something about it. That's kind of what I'm interested in. And I'm looking at how can I use technologies to enable pieces of that, right? And mostly games, right? But given all that, one quote that, well, that's me. One quote that comes, I hate presentations. It messes your train of thought. Right, my research area, right, and I'll get to the quote that comes to mind. Risk games, the logo is awful. I'm not a graphic designer, but that's what it is. And here's all the games that we've developed. Salt Tree Poker being one of them. EGC is working on Trust Me, but they have a much cooler logo than that. Right? It's a cool game for hopefully calibrating subjective probability judgments. Right? Haystack, which is a risk control measure, which is really a game that's outsourcing baggage screening, right, to the crowd. You can't do it in real time, but you can do it retrospectively to perhaps uncover false negatives that were found out. Have a student looking at that now. This is really a concept to elicit the fuzziness of words. So by giving them a game that's kind of a deceptive game, you want to find out just how squishy is the word about in conveying quantity. Here's another card game I developed, and I'm going to be running in a class next week for the first time. It's right over here. Security Risk Rummy, to teach basic risk analysis concepts to freshmen. We ran this. This is a mobile-based game to collect data on risk, observed hazards in the environment using mobile device. So it was a location-based service, and it worked out okay. We could improve it if we had money. Right? A board game we developed. This one we went to the White House for, CyberLink It. That's a game that's looking to elicit risk understanding. Sammy in the room is actually doing her Schreier's Honors College thesis on that. I'm looking at, you don't know this. You know Lisa? Well, what she's doing, and I'm just going to speak for you. We're going to take that game and to see to what extent does understanding of cybersecurity issues vary freshman, sophomore, junior, senior within the SRA program. We'll see what it looks like, because it's another assessment that's done on how well our curriculum is working. I can't wait to see the results. Right, but we'll send it to you first, right? But now we're doing that, and that's a cool online game. It's a game with a purpose. You know, I'd love to show it to you. Maybe I'll come and do another talk. This one, Kusanali. That's a weird name. I just came up with it yesterday. Literally, the name, right? Don't ask me how I came up with it. It's a card game that's meant to educate people on the difficulty of doing intelligence analysis, right? And in intelligence analysis, you do three things. You do collecting of information, you study the problem, and then you render a conclusion, right? So I was like, well, what are those words in Swahili? So I looked up collect, study, and conclude in Swahili, right? In that word, collect, study, and conclude, I took the first two letters of each of the translated words, and that's what I got, Kusanali. I think it works. Hey, hey, someone wanted to call it just Secrets and Lies. I was like, no, you got to call it this, because that's my story. Here's a game that's prototyped right now. It's really just paper and marker. I spent all night one night just coloring with crayon and marker, right? And we tried that game, and that's still in development and so on. So there's a bunch of games we're doing for various aspects of risk management, whether it be assessment, communication, and control, right? Today, the focus is on what I consider prerequisite to doing any of that stuff. It says the cornerstone. It's my favorite guy, Professor James Matsulat, who's an executive in the financial insurance world, right? He says the cornerstone of risk management is understanding. He says you can't really manage risk unless you understand it. But if you're an analyst, you really can't understand it unless you have the right tools. You can't just go and read something and say, oh, I understand it. No, there's analytic rigor you can apply to the way you study problems to enhance your understanding or increase the efficiency for time spent studying a problem. Make sure I have the right, okay. And you know, in the risk world, over the last 35, 40 years that this has really been a topic, it really doesn't go back that far. Risk analysis as a structured discipline, not including insurance, only goes back 72, right? I think the first paper using the word risk analysis was like 1961, right? It's not that far back, right? But nonetheless, over the course of that time, they developed a number of techniques for this. One of the techniques being fault tree analysis, right? But they've developed event tree analysis to help people understand how events progress in time and how branches could, go off, take the future in different directions. They have hazard and operability analysis, which is a method. So you look at a problem and say, well, the heater is hot. Why did that happen? Or, okay, now that it's hot, what can happen? It's just a structured way of thinking about problems. Fault tree analysis, which I'll show you in a second, is a very, very popular one in risk analysis. Very popular, very, very, very popular. To the point where if you go off and do risk analysis in any field except insurance, insurance is always the exception here in this talk, right? Whenever you go off and do it, except insurance, you will see it. Doesn't matter what your background is. If you have the word risk analysis, someone's going to present you with a fault tree, and they're going to say, look, there's a failure that's going to occur right here. And you have to be able to say, yeah, sure there is, right? You have to be able to interpret it, right? The challenge is it requires prerequisite knowledge that not everyone has in order to fully understand it. We have SRA program at Penn State. This is a very essential topic. If our graduates don't have this skill coming out, they are not going to look very smart when they're presented with this thing, right? But to fully understand it, you have to have a background in logic, background in probability theory, set theory, not a big one, but just know enough of the concepts to be able to look at the thing and say, I can understand what's going on. They don't really cover that so much right now. So what can I do in my class when I'm responsible for teaching this to make it so that they do get it without having to commit 5 lectures to covering background material that I really don't have the time to do? That was the motivation for this. Okay, so leads me to the game, and I'll show it to you right now. Pass it around. I'd love to play it, but you really don't want to be calculating probabilities right now, right? Right? I'll show you the game. I have a bunch of slides on this, right? But hold on, I'm not going to pass it around yet. Wait. It's a purposeful game. I don't use the word serious game. I just don't like it, right? And I'm allowed to say I don't like it because I'm an academic. Right? So I call it a purposeful game in the sense that by playing it, it achieves some purpose other than entertainment, right? Even though the player might be only playing it for fun. There might be some purpose that may be hidden or explicit, right? The game's to educate players on the simple use of it, not like these really complicated uses of it, but just the simple mechanics of how fault trees work, right? And the idea is through the course of play, we're going to require you to set these things up, and I'll show you what a fault tree looks like in a second. You're required to set them up. You're required to interpret them. You're required to calculate probabilities with them. You look at the impact of events and how it creates failure. Through all of this, through this game, we want you to be able to figure those things out, right? And I have some performance metrics to show that it actually does work, right? But with a caveat, right? So, quickly. There's a fault tree. Okay, no, that's not true, right? It's not that, right? That's a book called The Fault Tree. It's about a tree. I don't know what it's about. It's a fiction book, probably about suspense. Did you read that, Elizabeth?
No, I can imagine.
I have no idea what it's about, but that's not what we're talking about. We're talking about these mundane things. This is the cover of a very well-respected journal called Reliability Engineering and System Safety. Very well-respected journal in the reliability engineering world. And I have a PhD in reliability engineering, so my posse is in this journal, right? And look on the cover. You have this diagram. What is that? That's a fault tree, right? So right on the cover of the journal for reliability and engineering is the fault tree, because this is the analytic technique that was the one that emerged after, I guess, at the birth of reliability analysis in 1975. That's the method, right? Here's what they look like. At the top, you have a failure, something of interest to you that you don't want to happen. In this case, we're talking about loss of radar facility. A security problem, actually, that we'd be interested in. And it says, well, how can that occur? Well, it can occur only if this and that occurs. So it's basically taking a failure and you're systematically decomposing into what has to happen for that to occur. Then as you go down, well, fire. How does a fire occur? Well, either personnel carelessness or a malfunction can cause a fire, and so on. You can just keep breaking it down. The idea is when this is presented to you, you have to look at it and say, what is the one thing that if it were to happen would cause the whole thing to break? Or what's the fewest number of things that if they were to occur, the whole thing would break? In this case, those 2 things occurred, that would happen, just based on the logic, showing you how low-level things that you don't want to happen, right, cascade to create that really undesired end state. Very important technique. Very simple one. Here's one for security. This is dam security. This is from a methodology that's actually used to assess dam security. Not like that dam security. I mean like, dam security. Like big, like, what's a good dam? One in Oregon. What's that called? Right on the Columbia River. It's a big one, right east of Portland. Hoover Dam is a big one too, right? You're not taking the Hoover Dam down. Not that massive thing. But there's other dams that are smaller that can be accessed by vehicles fairly well, and the impact of, let's say, a bomb going off would actually be catastrophic, that are also very important dams, right? And this is just a generic fault tree for dealing with it. Again, our students from the SRA program will probably be presented with something like this, expected to understand it and make some sort of a judgment based on it. Or you can get more complicated. You can't see it, can't you? Right? I know this one because I did this one. Right? Well, at least I helped with it. This is for this spacecraft, and it talks about how little low-level events can cause failure of the mission at the top. Again, a system engineer will look at this and say, where do I need to focus my analytic attention so that we know whether we could be certain that that event doesn't occur, or we could put countermeasures in. That's it. See, very important stuff. They convince you. Are you just saying, yeah? You're convinced, right? Okay.
So why would you say that insurance is an exception?
Because insurance is mostly statistically driven, right? So it's like rather than trying to like describe the patterns, right? It's like they infer the patterns from the data using statistical techniques, and they have the luxury of all this data from which the patterns kind of pop out. It doesn't really matter why the data goes from one to the other. It's the fact that you see this causal relationships based on the variables and your dependent variable. The statistical techniques do this. In these cases, you don't have the database for it, right? So what do? You reason. So it becomes more reasoning, less data. And this is a reasoning tool, right? Especially in this, because you'll never get what's the probability of a spacecraft mission failure. You only have one. Right. And there's no, there is no other one like this. This is the hockey puck. I'll tell you what, does you know how this thing flew up? There was 3 of them. It would go up in a launch vehicle, and it would go like that. I remember I spent months trying to design that deployer mechanism, right? It was just a Frisbee. Nothing ever was tossed out like a Frisbee before. No data on that. But you know what? We had data on the solar cell, right? So that's over here, failure of one solar cell, right? We had data on some of the other stuff in there, but that's low down here. So the question is, how does our data that we do have map up to the answer we need? Insurance doesn't do that. If insurance had to do this, they wouldn't do it. The actuaries wouldn't sign it off, right? Because it's just not data driven, and it puts them at, exposes them to liability. So anyway, so now I'll pass it. The learning objective. I do have learning objectives because these taught me well. Learning objectives. I do have them. Define the terminology, construct them, calculate event probabilities, identify weak points, and so on. Right? The rest is now talking about the game. Let me just show you what it is. Here's the game. It's just this card deck over here. Right? It kind of looks like a big card deck. And everything about the game was created by me, even the design in the back. I haven't got it manufactured for a whole $15. Right? Game Crafter is your friend if you ever use it. So here, I have a deck of cards, 58 playing cards here. Actually, a little bit. 58 playing cards. There's 3 types of playing cards. 3 types of playing cards. This is what they call a basic event card. Pass it on. Basic event card. It's the lowest level of the default tree. You take the top of it, you break it down. At the bottom is the basic event. Talking to me? Hello? I guess it was me. Okay. Okay. At the bottom of the full tree is the event you have some idea what the probability is. Whether it be based on data or based on good experience or something like that. Bottom, most important thing. In this card, you have a circle. The circle is the symbol you use for an event. You have a letter in it. You have a letter in it. A symbol. Standard stuff. Color, I'll explain in a second. And associated with the event is a probability that it will occur. It doesn't say what specifically the event is, but we call it a P. And underneath it, the P is 5 over 10. Or 0.5, or 50%, because each one's completely a legitimate way of expressing chance. Right? So, and at the bottom, I have terminology. So as you're playing it, you're being exposed to the terminology over and over again. Right? That's one card. You can pass me around another one. Then, yeah.
Is the terminology important to the gameplay?
No.
It's almost like trivia.
Yeah. At the end, hopefully they've been reading the cards,
Right.
And we'll get to something about this later in regard to that. Thank you for asking that, because if I'm not there to facilitate it, there's no guarantee they'll look at the card that way, right?
If somebody asks you a question, well, if you could just repeat it and summarize it. Okay. Link's way up there.
Oh, should I do that again? Am I off the hook this time? Okay. For those listening to me at a distance, the question was, what was the question?
Is the information at the bottom of the card integral to the game play?
Is information bottom of the card integral to the game play? Answer was no, right? But when I step in the room and watch them play, it becomes integral, right? Because I make it integral, right? But for the person that's casually playing, no, right? So there's other types of events. Have these two. And or, right? And I think I could have it up there too, right? So and or, two cards, right? Again, using the exact symbols that you would use for in the fault tree, using the language underneath, and you see there's two ins and one out. That's a constraint that's not real. I could put a lot of inputs into it, but I'm restricting them to two inputs and one output. The idea here is they will take this card, and I'll show you a diagram, and to construct the fault tree, they start from a top event, and then they just connect events, and they work their way up. They just arrange it out on the playing field, the table. Again, showing you the symbols and the nomenclature and the language. Oh, and then I have the dreaded failure card here. I'll pass these around. Dreaded failure card. You have to take my word on this one, right? The failure card. If you get the failure card, this is your friend. Because the goal of the game, which I didn't state up front, I should have, is you want to produce, given the hand you have, the tree that has the lowest probability of failure. So you have to arrange the events in a way such that you have one event leading to the top event, and I'll show you some symbols later, and I have some examples. Or you have two events connected by a logical event to the top event, or maybe two logic gates and three basic events and so on. Your goal is lowest probability of failure or highest probability of success. Are those the same thing? What do you think? Probability of failure? Lowest? Highest probability of success. Is it the same thing?
Different.
They're the exact same thing.
Oh,
right?
I was going to say probably unless you have another category.
Exactly. They're mutually
Turned
exclusive.
off and it was neither successful nor.
So you have failure and success. Success is 1 minus failure. So if you want failure to be really low, that means success goes really high. So depending on what your orientation is, if your events mean failure, you want to get all the probabilities to be really low. If your events mean success, you want them all to get really high, right? And depending on how you flip a coin at the beginning of the game, which I'll show you in a minute, right, will determine what your orientation is for the round. And this is actually really important. This came out of playtesting. Originally, most people think of fault trees, so everything is negative. And in negative, you want a lot to have to occur for the top event to occur, right? You don't want to have a single point failure. You want 50 things to fail before that failure that matters to you occur. So do you want it to be A or B or C or D occur for failure? Or do you want A and B and C and D? What do you prefer? And. So what did people do when they got OR gates in their hand? If they had to use OR logic, this is poker. So what can you do with poker after you're giving cards? You discard some, right? What do they do with the OR gates? Get rid of them, right? And when they had to make a tree, if they had an OR gate, they would not use it. They'd rather use just one event instead of two events tied to an OR gate, because if you tie two events to an OR gate, the probability of the outcome is higher than the highest probability going in. So people didn't want to use it. And that defeated me trying to teach them half of the math. So I had to come up with a way that it would randomize what their orientation would be and still have the goal be the same, right? So I have a coin. So instead of a fault tree, you do a success tree, right? So, and you know what? Such a thing exists. So I'm not just making it up. It's in reliability engineering textbooks, and the guy who created it down in University of Maryland was very happy with me about that. He was on my dissertation committee too.
So gameplay question again then.
Yeah.
So if you flip the coin one way or the other, that's for their entire tree.
The entire tree.
So do you not then run into the same issue there?
But they only do it for one round.
For one, okay.
I can also change rules to make you use all your cards or something like that.
Yeah,
Make it tweak it. Right.
Trying to picture how it works.
Yeah. So technically, you'll only use one type of gate per hand. So when you start to mix gates, it becomes an issue. But then you have to impose other rules. But I'll talk about other rules later. Right. That's a good question, though. So, oh, and I forgot to repeat the question.
That's okay. I think it wasn't.
But anyway, let me tell you about why this card is cool. Okay, you have a hand. The probability of failure is not very good. Like 0.3, right? That's pretty high. Someone else has 0.1. You have this failure card. You're like, you know what? If I make one of your events fail, your probability is going up. Of course, if your tree is something simple, such as just one event. Now, if I make this thing fail, your probability of failure goes to what? 1, right? Now, if you have 2 connected together, if you cause one of them to fail, right, then 1 goes to probability of 1, and to get the output, it's just multiplying 1 times whatever. So the probability is going to go up. So if you really want to cause pain and you want to win, you throw down a failure card. But you can't just do that. I have to teach them something. So if you throw down a failure card, you have to do something else. Take your little spinner out. Sounds really hokey, but you have to play it. It's kind of fun, right? You have to spin this. It lands on A. This is not colored because I want it to be subject to chance. What types of events fail? I spin A. That means anyone on the table who has an event A that's purple failed. All of those go to 1, including yours, right? So you have to decide whether or not you want to risk it. So if you don't diversify, in the sense that if you say you had 2 low probability A's, but they're all the same color, if someone throws on a failure card, they might take you all out at once. So you might want to diversify, which is actually a very important concept in security and reliability. Diversification, right? One example would be if you have 2 redundant computer systems and you're worried about them getting disrupted for earthquakes, does it make sense to have them in the same building? Or does it make sense to have 2 computers and you're worried about fire in the same room, right? You might have a redundant system, but you're not really diversified. You might want to put it in separate locations, right? So it's another concept that I can get into them. It's also what they call common cause failure, because even though I'm treating these as independent, only one or the other occur, sometimes there are these big events that will just break everything in the room. And it's a way of teaching common cause failures. So I have a lot of stuff built into this thing, right? And of course, you can't be immune to actually having to create trees. I showed you the playing cards. These are what I call accessory cards, right? At the very top, you have a top event, because that's the event you care about. This doesn't really carry any weight in the game other than to say what color you are, right? And it gives you the top part of your playing field. So you'll set it down there, right? And then when you get your cards, you'll build off the top, just to kind of get practice with the nomenclature and the terminology, the symbology. So I call them accessory cards because they're really just for shapes and getting used to drawing it. Intermediate event is if you have a big tree, you can then organize it a little bit better by having this be an intermediate event that then feeds in that way and so on, you know, whatever. Something like that. No. Now, half of you can't see that, but I wish I could put a camera. So. And there's more. Of course, people don't know how to calculate. I'm not teaching them probability. They had stat 200. A lot of them forgot it, but they had it. They had to be responsible to bring something in the classroom, right? So, but I do give them a crutch. I give them cards, little calculation cards, right? Right there, right? Calculating probably at the top event, and logic. So you just take the numbers, and you say your probability of the out is this one times that one. You just plug the numbers in. I give them a calculator. You calculate it. Right, I'll tell you some cool story about that later. If you have OR logic, it's much more complicated a formula. Right? It's not really that much more complicated, right? People think it is, right? And if you have mixed logic, it gives you an example of how to do it. You're just building on those other two. People have used these cards. They start off saying, I don't know how to calculate it. Let me just plug it in the box. Let me tell you my anecdote. I had a student. He was an okay student. He didn't get an A in my class. Got like a B something. He couldn't get an internship. So he interned with me over the summer to do playtesting. And he playtested this, one of the first versions. And at the end, I played with him. And he didn't need to use a calculator at all. He said, this is probably 0.83. I'm like, what the heck? This guy knows how to calculate probabilities in his head now. Right? This guy would not do well in the probability tester in my class, but now after having done this, and after playing it over and over again, he's calculating them in his head. Not complicated, not those big trees, a little small one. But any small tree could be broken into little trees, and you just work it up. So I thought that was pretty cool, right? And those are helpful. I have some little results on that. Oh, and the last thing I give them, and were these consulted, I don't know, but just for the sake of it, I give every player a vocabulary card. So you see all these terms, they're at the bottom of the cards: basic event, incident, top event, I have intermediate event, so on. All of them are defined. Right? So you have the gates, probability, reliability, incident, everything's there. You can look at it if you have time. Most people don't, but they're there just in case. Cool? Let me show you some hands. Oh, here's some accessories. Remember at the beginning of the game, you flip the thing. Oh, you like this. Who knows what Monte Carlo simulation is? You're going to love this. Right? What if two hands are tied? Right, both have probability of 1.1. You know how we resolve that? A D10 die. You know what a D10 die is? 10-sided die, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what I do is if you have two hands that are tied, each person has to choose an event to simulate. And based on the outcome of a roll of the die, Monte Carlo trial, right? It's either going to be failed or occurred or not occurred. And then they use that result to recalculate the top event probability, settle who's the winner. So now they're doing Monte Carlo simulation. I don't tell them that. This is not something I intended to be a main learning objective. But later on, they're like, oh yeah, I remember rolling the die. Right? It's kind of a crude Monte Carlo simulation, but hey, it's kind of, it's built in. And it was a way to reconcile an issue we confronted, ties. Because there's only so many probabilities you can calculate. There's only 3 cards you can form, so many relationships, it's a finite set, right? We needed some way to reconcile ties. So anyway, so it's 2 to 4 players. I'll show you some hands. Rules of play is like poker, but you know what? I found that it's like a 52-card deck. It has kind of a built-in logic to it, right, that need not commit to poker. Just like a 52-card deck, you have an ordering to it. You have like the royalty and the numbers. You have 2 is greater than 3. You have ace that can either be a 1 or a big. You kind of have a built-in structure to it that allows you to build many games. And I'm convinced that you could probably do the same for this. So rather than beat one version of the game in, you could play all versions of poker. We played Texas Hold'em with fault trees. A little bit weird. A little bit weird, but we did it, right? 7-card stud, we did it, right? You could do solitaire. Actually, for constructing fault trees, you could just say, okay, here's 30 cards. You have to build a fault tree that has a probability at the top of this. Go for it, right? And you have to use all your cards, by the way. It's not easy, but it works. It accommodates multiple different versions of games. So here's just one game, and since we're not playing, I'm not going to go beat it to you, right? So let me show you. Here's an example of a hand. Someone flipped the coin. This guy is a success-oriented guy. That one's a failure-oriented guy. That means everything for the failure is failure. That means it's a failed event. This is a success event. Who wins? Lowest probability of failure, highest probability of success. Who wins? D wins. Yes. Simple. This is like the most boring fault tree ever. Just one event feeding into a top event. Next. I'm not going to tell you who wins here. Yeah, now you have to calculate, right? Actually, maybe I should let's do it. Who wins? You have 2 hands. One guy that's failure-oriented, the other one's success-oriented. What they have to do in the game. Failure? This is probability. Both time together. 0.12, right? So it's 0.88, probably a success. Here it's 0.9, or I'll tell you right now, it's greater than 0.9, right? So after a while, you can learn a pattern, right? If you want to calculate it, 0.9 times 0.9 is 0.81, plus 0.9 is 0.71, minus the product of the two is about 0.72. We're talking 0.99-ish. So the probability of success here is 0.99, there it's 0.88. This guy wins, right? Right? I did it fast, but after people play it, that's how they're doing it, right? They're also noticing the pattern. It's like, well, I know that's 0.9. It doesn't really matter what this is. It's going to be at least 0.9. And you have 0.88, I win. And that's good because we don't need people to actually have to take a tree and calculate the whole thing every time. They just have to be able to look and say, that's the cause of your failure. Oh, that's the cause of your weakness. Oh, you have 2 trees. I want that design, right? And they get pretty quick. Surprisingly, it looks kind of complicated, right? But people get pretty quick at it. Anyway, different analogs and stuff. And people use money too. I give them money. Right. And the remarkable thing is when they start to use the coins, you know they've kind of gotten somewhere with it. and they're actually playing it for fun. You have this big pot of money. And I don't advocate using real money in the classroom. That's not my thing. But I do. I used to give them paper money too, not real paper money, but you know, the coins now seem to be okay.
Do they cash in their chips for
No,
grades? Or?
no, absolutely not. The RB will not allow that. Right, so
Are the coins chocolate?
that's actually a good idea. Chocolate coins. Anyway, so that's the game. I have a couple more things that are actually probably the more interesting part of the whole thing, but I like the game, right? So development. See how I wrote playtesting, more playtesting, more playtesting? I conceived of it in June. I was in my living room and I was like, I want to make a fault-free card game. Literally, it wasn't like, oh, well, how can I satisfy a need? It was just flat out, I want to make a fault-free card game and justify its existence. So that's how it happened, right? I was just being a game designer and then found that, hey, I can actually justify doing this on my own job time by connecting it to work, right? And I did. So that's what we're coming up here. So I conceived it in June 2010. I used a bunch of students for playtesting that needed internship credit, right? And they playtested it. And I have little blog posts I wrote about it along the way. We played different versions, cruder card designs. We had multiple decks. I'm saying we had tried everything. What we have now is after 12 playtesting sessions, right? Over and over again, right? Even this version now is not the version I played with actually in the experiment I'm going to show you. The next version is the final version, hopefully, right? And we did pilot testing in October. And I did show and tell with a lot of people afterwards. So here's a bunch of pictures of people. You can't see it. That's great. But here's one playtesting session, and that's me playing it in the classroom. Test it with a bunch of classes. I got IRB approval to do anything I want. It was great, right? I went and said, I just started talking to the IRB officers, and I said, okay, I want an IRB to test any game I want in anyone's class. They said, okay, this is how you do it. And I wrote it, and I got it. So I just can't test it in my classes. I can test it in anyone else's class. So I spent last semester negotiating with lots of people to let me teach their classes. So a lot of people like me now because they didn't have to teach several lectures. Right. And all of them were security classes. I did SRA 311. My counterpart, Dr. Ed Glantz, was teaching it last semester, and I took over his class for 2 lectures. I went to Harrisburg. The guy who was supposed to teach SRA 311 at Harrisburg quit, and they had to throw in someone at the last minute, and the guy was grateful to give up a lecture to me. Right? He played, and everything was good. I did IST 456 in 2 classes, and that's a follow-on class after SRA 311. It's another risk management class. I did about 115, 120 students that I tested, and each class was a different experience. And I'll make this point right now. When you're having to be constrained by what the class structure is because of the way the teacher runs it and the scheduling and it makes every single class a completely different experience. Right? And you go in with a plan, right, that plan goes apart. So it's really, really hard to prepare for experiments when you're using other people's classes. I can tell you that right now. Each one of those experiments was completely different. Even the same class was different, right? Because you don't know who's going to show up, right? If you want to have a statistically significant sample and you have 3 different groups and only 40 people show up, you're only getting 2 groups, right? This Harrisburg, 10 people showed up. And it was a 3-hour class. Everything else is 75 minutes. What do I do? 3 hours, and I have to do the whole thing, and I had 10 people. Real-time renegotiation of experiment. It was pretty intense. In the end, I only used the SRA 311 because it was the cleanest. It had 54 students, had 4 groups, 13, 14 each, but I'll explain that in a second. But it was a good experience, all of those. Here's some questions. Does it improve player understanding of fault trees? Does it decrease test answer aversion? I made that up after the fact, right? I'll explain what that means in a second. Is fault tree poker better than a lecture? Better than my lecture? That's what it came down to, right? You can't really answer that question very easily because it depends on who it is, right? And is it fun, right? Methods, I did a pre-test post. This is new for me, I'm telling you. If I sound really ridiculous up here, it's because I've never, ever presented anything like this in my life, right? I did a pre-test post-test design. I had 2 groups, lecture versus game. Each group was divided into 2. Half of them did pre-test, half of them did post-test. Randomly selected when they entered the class by way of distributing a quiz that had a marker at the top of the sheet, right? Afterward, all test items on the pre-test and post-test was a 5-item forced response, which was my creation, I think, right? 4-item forced response, but I don't like noise. I don't like people guessing and screwing my results, right? I wanted them to say, if you don't know the answer, put X, you don't know, right? I did not want people to have to guess, and they all agreed to that. right? And that's why I say test answer aversion. I wanted to see if people were willing to take a chance in answering the question, and they did, right? And that actually really helped for keeping the sample size down, right? Because if they put X, it was wrong, right? So there was a lot of wrongs because they feel they didn't know the answer rather than guessing. If I had to have them guess, the sample size would have to go up for the same level of significance, right? I'm not sure if anyone's done that before, but I just made it up. It seemed to work, right? 2 post-tests delivered. I did one right after class, opportunistic. I did one right after class, and I got another lecture afterwards. So I did it the next lecture too to see what would happen. I have a cool result there. Everyone completed a survey, and I handed everybody the same printed materials afterward. So after they either had a lecture or the game, I gave them a handout that explained everything they should have learned in the lecture or the game. And the lecture was calibrated to the game. So everything I wanted them to learn in the game, I taught in the lecture, no more, no less. Everything. Everything I did here was exactly the same. I have all the materials. Oh, and I had questions I had to ask them for the pretest posttest. So I made up 30 questions, but I knew, thinking sensibly, that what do I know? I just made up 30 questions. How do I know they were good? I never heard about test item analysis, ever, right? In fact, I didn't know until last week what that was, right? So what I did was I said, let me come up with 30 questions and ask everyone I know in the field that teaches this and claims to be an expert how they would rate each question against the 5 learning objectives. So I said, if the correct answer to this question provides evidence that the student can each learning objective, and I had them assess, strongly agree, and so on. So I created a test of 20 items that was scored such that across every learning objective, you had the same points, right? That way it was balanced, and also the questions had to be rated as good, not bad questions, and they had to be rated as somewhat difficult. So I asked those questions. So I came up with a 20-item test that you look at it, it's like, wow, that's a pretty good test. But I didn't do test item analysis on it, I feel bad. Right? Maybe I'll go back and do that. I just didn't have enough samples, right? So what am I going to do? Right? I consulted about 10 people, and I said, oh, let me take 15 minutes to get back. They said that was 45 minutes. Because 5 questions, 30, that's 150 responses. Plus, I asked them for feedback and difficulty and whether or not this is a good question. They were really mad at me. I owe them a lot, right? So here's some results. Everything was a p less than 0.01, and it's non-parametric, which is kind of remarkable to think about it. Non-parametric doesn't have as much power as these parametric type methods, but I can't convince myself to use parametric for anything, right? I'm a non-parametric guy, right? And I got pretty good significance there, right? And I showed that game helps, pretest posttest, right? Game shows an improvement. Lecture helps too, right? And there's a weekend effect. The weekend effect was after they played the game and took a test, when they came back and took the test the next lecture, their scores went up again. I have no idea why. Right? The lecture it didn't happen, but the game it did. Right? Of course, the lecture they got pretty much 11 out of 13. Like it was pretty high scores anyway. The game after they played it, they didn't get as good as the lecture, and actually after the weekend they didn't either. We'll talk about that in a second, right? But after the weekend, their scores went up relative to what they did right after they played the game. Don't know why, but it's there with that p-value. And I did the non-parametric test, and I convinced myself. Right? Same thing. Their confidence in answering questions went up. Right? People actually started taking a risk and answering more questions. Right? And I'll show you that in a second. See, it's like distributed over there. 0 is a good thing. 0 means I had no X's. So you see this big spike at the lecture, and over there it's not so much. But you see, after a lecture, right, people were willing, who took the pretest, to actually try and answer questions, which was interesting. So, and here's the post-test comparison. So first post-test, these are bar graphs. They're probably an awful way to communicate these results, but hey, whatever, right? So I did post-test for lecture group, second post-test lecture, and compared it against the game group. And I found that after the first post-test, the lecture did better, right, than the game. Let me tell you, the game was not facilitated by me. I gave them a box with instructions that said play it. And they took a test afterward. I wanted to see if the game in itself could function by itself. I don't think it can, right, after the results, right? And that's going to lead me to something I'll talk about later. But their scores went up over the weekend. Maybe they were motivated now. I don't know, right? After the lecture, at glance,
Oh, sorry.
you remember the lecture, right? She was in the lecture, by the way.
Yeah. I just an idea of maybe like what would cause the weekend effect. we came out, people that were in the lecture like, oh, well, what were you guys doing? And they went through and explained the whole game to us, and I guess maybe getting them to talk about it, and they were like, oh, so that's how that works, and yada yada. That was my
Interesting. So there's like a little social dynamic thing going on.
Could you kind of summarize what you said?
How about you summarize?
So far into
I think you got it.
Okay, a student that was subject to my torture in the class last semester, she said that after class, the students that were broken into two different groups, right, talked with one another about their different experiences, and then one of them, or a few of them, would say, "Oh, that's why something happened." Kind of like it clicked after the game.
So were you saying that the people who did the lecture were explaining to the people who were playing the game, or was it?
It was sort of both. We were all interested. We weren't told that they were playing a game, so we just told they were doing something. We all wanted to know what was going on, and then they explained the game to us, and I guess it's sort of like a two-way conversation. And certain things were put with them, and then we learned about their game strategies. And I suppose those who are playing the game would talk to other people playing the game and would tell them why they would do certain things. I guess like the animal words, and like didn't pick up on that immediately.
Cool. I didn't know that happened.
So did you, I was going to ask about that earlier. It seems like you need to have some kind of reflection. You didn't build reflection into the...
I have a slide on that.
Okay, sorry.
So the question was about reflection.
The question, oh yeah, it's so high paid. And Lisa Lenz has a question. Lisa, what was your question?
I was going to say, I think went to just the lecture.
And I'm kicking myself now for not having had a survey appended to the second test to say, to what extent did you, I think I asked, did you study the material? No, actually I didn't ask that. Did you study material? I should have asked, did you discuss the material with someone else afterward to see if I can correlate that again? I wish I did. Again, mistake. But it was good. The data showed something, and now you guys are helping me explain it. That's good. Pretty cool. But in the end, the game didn't do as well as the lecture, even in the second post test. It was very close, but it was less, right? That's okay. I have a strategy, right? So here's a performance summary. FTP helps, they call it poultry poker. No pretest effect observed. I didn't mention that, but there was no pretest effect observed. The pretest didn't prime them. It was not there. 2.01 unless it's actually really low, like 10 to the minus 5, right? My lecture better served the students. Afterwards, Egg Lance came in and said, "You just killed your experiment." That's what he said to me. He came to me afterwards, just like, "I don't know how you're going to beat that." I don't remember how the lecture was, right? Right. Afterwards, he's like, "Dude, right, you should have been bad."
I think also you're a very animated speaker, and so a lot of the students can focus when you if you perhaps were more.
Yeah, I have a point about that in the next slide. Right. To how I could have gotten better results. Right. Right. And they went up over the weekend, and I'm glad we talked about that. And people found it to be more interesting than lecture, based on some sort of results. And I only did a 13-question test, but I really wished I did a 20-question test, because I felt 20 test items would have been a little bit more discriminatory between the performance of people after the intervention. So, and I have a 20-question test. I just decided to shrink it down to 13 so I can get more playtime in the session. Right? So here are some results. And here's another interesting thing, because it has nothing to do with poultry poker. Right? But here are some results. Forget the numbers. Let me tell you what was really cool. I have a psychologist as a postdoc working for me, and he does this stuff all the time. So he said, "Did you do a factor analysis?" I'm like, "Factor analysis? What's a factor analysis?" And I'm looking at these 8 emotional elements that you have in your little write-up part. You have a citation for it. So we did a factor analysis, right, by that guy, right? And then we looked at We were able to get a clean 3-factor solution, right? For fun, challenge, and educational, we came up with those labels, but they were linked to some emotions. Fun is over there, challenge is the next one, and educational. And then get this is like the most sophisticated statistical analysis ever done, right? In the game context, when you put those three and you do a regression analysis, you find that fun explains most of the variance. That is explainable, right? There's also, the R-squared is not very high, right? But for that, it's there. It explains most of the variance, right? But in the lecture context, fun doesn't explain anything, right? The regression model is different, right? This was interesting. I'm not sure if this is interesting to you. I thought it was interesting, right? But this is actually consistent with the study we did over the summer, where we showed that fun was the dominant factor, and then there was also a 3-factor solution. So we would map these 8 emotional elements to a 3-factor thing, and then do analysis on that, and actually do better analysis with higher power than 8, right? So it was pretty good. But here it was interesting, just doing the regression, it said fun had no bearing on test performance, whereas in the game, fun had all of it. The education was based on how they self-reported. So it's interesting. So I'm still thinking about that. I have a bunch of games I'm playing that ask the survey over and over again. I want to come up with a fun assessment questionnaire, which seems to be lacking, if you haven't noticed, right? So, but we're finding a pattern. It's repeating itself. I think we could add some more emotions or something to get a better instrument. So, almost done.
Here's something that came from one educational difference described by Solomon as the amount of
That will be a paper I will read next. Thank you. You know this. You're like nodding. You're like, yeah.
Media effects.
Media effects. Engineer, media effects. That's good. Thanks. I need that name. Solomon, right? I'm going to ping whoever about that one. Good. Thanks. I appreciate that. So,
Gabrielle Solomon.
excellent. I really appreciate that. So, what else? There are some other questions I asked, and I'll tell you again. You're going to be like, William, what were you doing? It occurred to me after doing this that you ask survey questions to help explain variance, not you asking them just to ask. Sounds pretty stupid. I'm saying this. But it was a reflection. I realized I asked too many questions that I didn't know what to do with at the end, right? Now I know better. Next time my instruments will be way more tuned, right? There's nothing like doing an experiment with human subjects to teach you something in real time, especially when you're doing it with a classroom that is unpredictable. It's great. So here's some other things I asked just about the game to see how people felt. Again, it was like this: 1 was strongly disagree, 5 was strongly agree, and no one liked my instructions. All I did was give them the box of instructions. They said that was not good enough, right? In another class where I sat down with them, the Harrisburg class, they broke into groups. I went to every single group in play with them one-on-one. That wasn't an issue. But for the SRA 311 class that did not have me, it was an issue. Fair enough, right? But they said the calculation cards were helpful. Remember, I showed those cards, right? People didn't really agree to saying they were good at the game. They were kind of like, in between, and so on. Learning to play the game. In the 311, a lot of people felt they still didn't learn the game after the class because they only had 30 minutes to play, right? Time was short, 75 minutes, especially with post-test, pre-test, and so on. A lot of people like playing games and so on. But this is interesting. It helped me think about what they were experiencing there. I really didn't do any analysis other than averages there. But I did get some feedback, and this is way too small for you to see. A lot of them are like, wow, that was novel, right? Right? Oh, I wish people would do this in my class. A lot of people said, well, yeah, it's okay for class, but I'm not going to play it for fun outside of class. No. Interesting feedback, and I use some of these things to help improve the next iteration of the game. Right? Nothing that really stands out. They're generally consistent. I just summarized all responses there. And how can the game be improved? I always ask this question, and again, some briefing on fault trees beforehand would have made the game far more effective. I take that to heart, especially after the fact I read a lot of simulation and gaming literature, and had I tried to get this published, and I did not have the debriefing part integral to the experience, I would not have gotten accepted. I would have gotten rejected right away. So I learned that. So anyway, I wish I asked better questions. What did I do wrong? I think the lecture might have been a tad too good, right? So next time I want to do good teaching negatively impacted my results, my desired results. right? I'm not saying I was a great teacher, but I had the thing completely worked out, and it was timed and everything. It was like most I ever put into any preparation for any class I ever gave. Right? Go figure, it had to be an experiment to drive that, right? But nonetheless, I did it, and at the end, did I screw myself, pardon the language, because I put so much attention into it, and I had nothing to do with the gameplay experience, right? So
The idea behind putting all that effort was so that you.
in the lecture, I just wanted to, I had to make sure it would fit within a certain time window, and I had to make sure that all the content was covered in a way that I wanted to be unfair to myself, right? By forcing it to be as good as possible, so someone could say, well, you just didn't. Basically, I was almost defeating my results ahead of time, just to see if maybe the game potentially would be better than anything I could do, which turned out it didn't, right? So, which was good information, right? It was hard to interpret, again, these survey results because I asked too many questions. You know, this is me reflecting on me and my experience doing human subject research as an engineer, which I really wish more engineers had the experience doing because it's amazing, right? And I did not include an effective debriefing. We're almost done. Oh, dude.
I was just going to say, it was interesting. Most instructors got in it some kind of setup. So to have somebody else as the way,
All right.
a guest lecturer, someone try to use it.
I have a point on that. This brings me to almost what I'm done. Must include debriefing. This is my next step. First, I'm going to actually test this again in my classroom, which requires a whole new IRB, right? Which is annoying because there's a lot more stipulations I have to adhere to, right? With getting consent and stuff like that. But now I have the luxury of 3-hour class. I have a 3-hour class. I'm going to break it into 2 pieces. One, you come in, you play the game. Part 2, you hear a lecture, debriefing, right? But I could break into 3 groups: game only, lecture only, and game and lecture, right? And I'm almost certain that this is going to show superior results compared to the other 2, right? That way I can get my paper published, right? And also be like this to test out the final version of the game, right?
So it would be like the same block of time. Game and lecture, it's not going to be like one.
It's a 3-hour block. I'm gonna break it into, I still have to get the numbers and random assignment, but I'm gonna have people come into the game, and then after the game they do their little survey and leave. Then there'll be people who play the game that stay for the lecture, and then after the lecture they leave, and then people who come just for the lecture and leave. So it's gonna be just in that sequence.
2 things from all. Lecture supports the kinds of learning outcomes that are typically successful. Do better, intuit the risk. And then Roy also said, can you design a test that measures?
I will consult someone else about that because I never really thought about that. Right? Can I? Well, one that like describing in words, maybe an open-ended question, how this would be solved, or how would you interpret it? I'm talking to you as though you're the person saying the question. That's good.
Roy says yes.
And I say, Roy, please call me so we can talk about this because I would love to. I have plenty of time to get this prepped, right? The RB doesn't really care what instrument I give them; they just care about me not coercing them, right? So I have time to package an instrument, right? And I was going to do a post-test the next lecture as well. I was going to give them time to actually think about it and study it, and prepare because their grade matters in this case, and so on. And I was going to use 20 questions and so on. And I have 58 people, 62, but 4 of them played the game last semester. So there goes 4 data points. Anyway, almost done. So this is the last slide. Miscellaneous factoids. I actually have a guy that from Russia, the Russia Academy Assignments, that really liked the game, and he's like the reliability analysis god of Russia, right? And he translated the whole thing into Russian. I just have to copy and paste it into the cards, and I'm going to make him a Russian copy. So it's good. A person who would actually probably endorse my tenure package later on, full professor who's really senior in the risk analysis world, loves the game, and she's going to audition for class this semester. And I'm going to ask her if she can, if I come up with a meaningful instrument, and see if I can get some data from that, right? But she's using it. She's like, she's Really excited, and I got some consulting work out of that actually to teach DHS people. That's good, right? And again, it's just one possibility. You could do a lot of stuff like this, right? I think, right? But I'll leave that to other people to explore. I want to make other games because there's lots to be made. So anyway, so that's that. And there's my, how you find me.
So is that for real?
No, that's the search term you add in the Google box.
Okay, Roy was asking.
I will do that, and I'm going to do it in a way that's the easiest. You're going to like this, right? All right, I'm going to do this. There we go.
So if we wanted to get a copy of this game, how would we do that?
Okay, I made it available on Game Crafter, right? Cost materials, right? So, and they make profit off of it. I don't, right? Because I'm not allowed to. Nor do I really want to. Well, I would want to, of course, but no, I'm not going to do that, right? But you can go online and get it, thegamecrafter.com, or you can just type Fall Tree Poker. There's only one use of the phrase. No one's crazy enough to put those three words together. Right? So if you search on the term, I come up top. So and it's like $20.07 because of the materials. Right? And, anything I did wrong? I think I did kind of right. Say and I'm an engineer, and again, human subject research. Right? Nothing's more frustrating and kind of exciting than that. It's frustrating during it, and afterwards when you get results, you're like, hey, wait a second, I have results here. Wow, it's amazing. I actually can say something with confidence for once, right? As opposed to just speculating that it will work. So,
Thank you very much, Will.
no problem. Thanks. Pack this up. Sorry for going over.
Really cool thing about that possible weekend spectrum.
Yeah.
We're actually talking to each other.
Do they really talk afterward?
Oh, yeah.
I didn't know students talk to each other. To me, they're just all independent entities that sit and stare at me during class.
Didn't know about